Hi, I'm Dara. Welcome back to another episode of SwiftUI apps. This time, though, we'll focus on the UI, not the whole app. In this project, we will implement the UI design of a thermostat that is usually found in a smart home app. This exceptionally beautiful design was created by one of our designers, Aksonvady. You can find it easily on the Figma community. There's even a tutorial on YouTube that shows you how to build it from scratch. Here's the link. For the SwiftUI project, we converted one of the screens to a dark mode version and cut a few elements to simplify it. On the thermostat screen, the top illustrates the thermometer and the bottom cards the smart systems. Aside from just implementing the design, we'll work on its functionality as well. The gray circle is the dial, and the point close to its border represents the target temperature. The colorful progress ring, on the other hand, indicates the current temperature, which you can also read the number. If we turn the dial to change the room temperature, we'll be able to observe the progress or regress of the current temperature as time passes until the target temperature is attained. In the middle, there's a status indicator informing us whether we're in heating or cooling condition. It then disappears when the temperature is reached. Moreover, we'll ensure to restrict the temperature setting within reasonable bounds. This is going to be one cool project, pun intended. Let's get started. Let's create a new Xcode project with the iOS template. Name it Smart Home Thermostat. Create. Close the right panel and change the simulator device to iPhone 13. Resume. We'll start with all the prep work first. This app has an extensive color system. Thankfully, we'll only take care of the dark mode. Go to the Assets folder and create a new folder named Colors for organizing all of our color sets. It's best to assign color names by their usage. Open the Inspector panel and make sure to be on the last tab, Attributes Inspector. Create a new color set for the background. Select None in the Appearances drop-down. Click on the Universal Color card to change its attributes. Make sure the content is sRGB and select 8-bit hexadecimal as the input method. Copy the hex color code from Figma and paste it here. Now repeat for all other colors. I'll forward this process. Alright, we completed all of our color sets. Close the right panel and the Assets tab. As you notice, there will be a lot of gradient colors involved. To type easier, we can make an extension to linear gradient in a new Swift file. Create a new file. Extensions. That way, most of the time, we'll just need to pass the colors only. Extension. Linear gradient. Selecting linear gradient will automatically import SwiftUI. You may remove foundation. Then set up a new init method to accept colors. This is going to be an array of colors. And start point. It's of type unit point, defaulted to top leading. Endpoint. This one is defaulted to bottom trailing. In the closure, add self.init with colors, gradient, initialize gradient for colors as our colors, and start point is the start point, endpoint, endpoint. Now go to Content View to configure the foundation of the main screen. Add a navigation view and set its navigation view style to stack. Let's apply a background color to the whole screen. Add a Z-stack and initialize a color instance with background and ensures it in your safe area. Finally, set the navigation title to Thermostat. And the navigation bar title display mode to inline. The title is black in the preview. Change the preferred color scheme to dark to make it white. There you go. Let's add in the components. I suggest we start with the simpler one, the card. Create a new SwiftUI file. Called Climate Card. This component has three properties: var, icon name, string, var, index, string, and var, measured, string also. Fix the preview by passing in map values to the props. Humidity dot fill. Inside humidity 50%. Resume. To form the card, we'll go with the Z-stack approach instead of the V-stack because of the shadow. Otherwise, applying a shadow on a clip shape would look weird. Z-stack. This is the card. Rounded rectangle with corner radius 22 and style continuous to smooth the border. Let's apply a color to it with the card background. Then add a shadow. It's going to be the card shadow with the radius as specified here, 40, x0, y20. Then the size of the card is 144 pixel by 164 pixel. So let's frame it. For the preview, we'll be able to see the border color properly if we apply the background color as well. Background, color, background. In this case, it's fine to modify the frame size to infinity of the whole view since it's the preview. Frame, max width, dot infinity, max height, dot infinity also. Heads up, we'll be repeating this practice. Let's zoom in the canvas. Now let's draw the border on top of the card. Dot overlay. This is the card border. It's just going to be the same rounded rectangle. But in the form of a stroke. White at 10% opacity. And the line width is 1. Now we can see the border. We'll wrap the card content in a V-stack with the spacing of 10, 10. This is the circle icon. The icon is from SF symbol, so let's use image with system name, icon name. Size is determined by comparing the pixel value in the design with Apple's typography. The size is 22 pixel in semi-bold. So let's go to Apple's typography. 22 pixel is equivalent to Title 2. So font, Title 2, weight, semi-bold. The foreground color is white. To make a round background, set the frame first. The width and height is 60 pixel by 60 pixel. Remove the alignment. Apply a background color of linear gradient with the colors temperature ring 1 and temperature ring 2. The start point is top and the end point is bottom. And clip shape with the shape of circle. Let's not forget to add some padding for the content. The vertical padding is 20 and horizontal is 10. Padding, vertical, 20. Padding, horizontal, 10. For the two indicators underneath the circle icon, we'll wrap it under another V-stack with a spacing of 8 this time. Then add two text views for the index and measure. Text, index. The font is 17 pixel in semi-bold. So that's headline. With foreground color, white. For the measure, the font is 20 pixel in semi-bold. That's title 3. Font weight, semi-bold. The foreground color is white. At opacity 0.6. At this point, the climate card is completed and ready to be used. In Content View, add a scroll view underneath the background color. To remove any spacing between elements in the scroll view, insert a V-stack with a spacing of 0. This is the Smart Systems. Then we can call twice the climate card, wrap in an H-stack with a gap of 20 between them. The first is the humidity card, climate card with icon name humidity.fill, index inside humidity, measure 49%. The next card is the temperature card, climate card, icon name thermometer, index outside temp. The measure is minus 10 degrees. The shortcut to type the degree symbol is Shift-Option-8. Voila. Next off, we'll build the top portion of the screen, which is the thermometer. Basically, we'll handle all the round elements from the placeholder to the set point. Let's begin by inserting a new SwiftUI file. Name thermometer. This component has many elements that sit on top of each other, so we'll wrap them in a Z-stack. We'll group most of them in its own file to avoid too many lines of code here. First, we'll put down the placeholder, and we'll create this component in a moment. Thermometer, placeholder, view. Let's apply the same background to the preview as in climate card. Now create another SwiftUI file for Thermometer Placeholder view. Resume. We'll define a constant for the placeholder size, private. Let placeholder size of type CG float. The value is 244. Then make a circle. Resume. Fill it with the reserved gradient colors, linear gradient. The colors are color placeholder 1 and color placeholder 2. Then frame it with the width and height of the placeholder size. Finally, add a drop shadow. The color is color placeholder drop shadow. Now for the radius X and Y, let's go check out in the design. X0, Y15, the radius is 30. So this is the drop shadow. To see the shadow clearly, we're going to change the background color to the preview, same as before. Copy, paste. The placeholder has a border. We'll apply the same method as in the climate card with the overlay. Overlay, the content. It's going to be a circle with a stroke of content and line width. The stroke color is a linear gradient of black at opacity 36% and white at opacity 11%. And the size of the border is 0.84 pixel. So linear gradient, black, dot opacity 0.36, white at opacity 0.11, and the line width will round it to 0.8. For the placeholder's inner shadow, we'll add another overlay. We'll draw a round stroke. The stroke color is going to be placeholder inner shadow with line width 2. The width of the stroke is an estimate and based on deduction and trial and error because it's not defined in the design. Then blur it with the radius of 7. Offset it a bit with X0, Y3. 0 and 3. And finally, mask it with another circle. Let's fill it with the linear gradient, black and clear. The start point is top and the end point is bottom. The masking gradient color is irrelevant. It's the color opacity that matters. By applying the mask this way, we're clipping what's outside of the circle. Close this file, we won't need it anymore. The following element to put down is the ring. We'll add it directly in Thermometer view. Let's declare a constant property ring size. Private let ring size CG float equal to 220. Also, declared a state property ring value of type CG float also defaulted 0.5. Resume. The stroke is essentially a wider round border trimmed down to leave it open. Circle. Stroke with content and style. Linear gradient of colors. Temperature ring 1 and temperature ring 2. The style of the stroke style, the line width is 10, line cap round, line join round also, and let's remove the other parameters. Now let's trim it. The from and to values are determined according to the minimum and maximum temperatures, which are respectively 4 and 30 degrees. 4 degrees is equivalent to 10% of 360 degrees, and 30% is 3/4 of it. However, instead of 0.1, I'll put 0.099 so that we can always still see a bit of the ring when it's at its lowest setting. The circumference of the stroke is the minimum of the ring value to 0.75. Let's resize it. Frame width is the ring size. Same with the height. No alignment. We'll rotate it 90 degrees to start at the bottom edge of the circle. Rotation effect, decrease 90. And let's animate it. Animation, linear, with duration 1 second. The value is the ring value. Also, we have to make sure it falls within the frame by insetting it by half the stroke's width. Otherwise, it won't touch the dial. Here, inset by 5. The inset modifier is used to keep the circle at its original size, similar to stroke border. However, stroke border cannot be paired with trim, so we use inset instead. If you want to view the effect of the animation, you can update the value of the ring value on a peer of the Z stack. Let's see it. On a peer, ring value, let's put it to 1. Run the preview. There. Now that you've seen it, we can undo this. The remaining round elements together will compose the dial. For this purpose, we'll create another SwiftUI file. Name thermometer dial view. We'll define constant sizes for the inner and outer dials and set point to make them clear. Private let outer dial size CG float equal to, let's get it from Figma, 200. Let's copy this and paste twice. So the inner dial size, it's going to be 172. The last one is the set point, 15. As well, we'll pass the property degrees, var degrees of type CG float, defaulted to 0. For the body, start with a Z stack. Resume. Let's apply a background color to the preview here as well. Copy. Paste. Let's lay down the outer dial first. Nothing new, it's going to be yet another circle, but with 2 drop shadows. Inside the Z stack, this is the outer dial, circle, fill, with linear gradient. The colors are outer dial 1 and outer dial 2. Let's frame it with the outer dial size above. Then apply the shadow. The first shadow is black at opacity 20%, blur radius 60, x0, y30. So black, opacity 2.2, radius 60, x0, y30. Let's comment this to indicate that it's the drop shadow 1. Let's do the same for the other shadow. The next shadow is black, opacity 20%, 16, 0, and 8. Black, opacity 2.2, radius 16, x0, y8. This is the drop shadow 2. Next, trace a border on the outer dial. Overlay, circle, stroke, linear gradient of colors, white, opacity 20%, black 19%. White, opacity 0.2, black, opacity 0.19, and the line width is 1 pixel. For its inner shadow, apply the same method as that of the placeholder. Overlay, circle, with stroke, white at 10%. White opacity 0.1. The line width is 4. Blur with radius 8. Offset X3 and Y3. Mask, circle, dot fill, linear gradient, black and clear. Right inside the outer dial will be, of course, the inner dial. Circle, fill, linear gradient again, color, inner dial 1, and inner dial 2 with the frame size, inner dial size. It's getting there. We'll add the dot inside the inner dial to represent the target temperature. Actually, correction, the set point is one word. So circle, fill, linear gradient, color, temperature, set point 1, and temperature set point 2. Then set a frame to the set point size. Resume. As you can see, the set point is in the middle of the dial, not at the right position. To push it to the corner of the inner dial, we'll need to set a second frame whose size is the inner dial size with top alignment better. Then add a vertical offset for a little padding. Offset x0, y 7.5. Allow it to rotate according to the degrees value. Rotation effect dot degrees and degrees. The set point position starts at the top, so rotate it by an additional 180 degrees. Finally, the set point moves as the user turns the dial, so let's include some animation. Animation.ease in out with duration 1 second, and the value is degrees. Finally, let's show the thermometer dial in the thermometer view with the degrees parameter, for which we'll need to define a state variable for it. At state private var degrees of type CG float. Here though, default its value to 36 to match the ring. Resume. Then add the thermometer dial under the ring. Thermometer dial view, degrees, is equal to degrees. Afterwards, we'll implement the UI design of the remaining elements of the thermometer: the status, the current temperature, echo leaf, and the whole scale. First off, the status can only have 3 values, so we'll set up an enum for it. We'll be using it in this file. Enum status of type string case reading, and let's write in cap case cooling and case reaching. We'll bind the status, current temperature, and echo leaf together as the summary. Therefore, create another SwiftUI file for it. Thermometer, summary, view. Resume. There will be 3 props, namely status of type status, show status, bool. The purpose of the show status is to hide the status at the beginning and when the target temperature is reached. And temperature as a CG float. Let's fix the preview by passing in parameter values. Status dot heating, show status true, and temperature 22. Resume. The whole view is going to be a V-stack with a spacing of 0. We have to account for the big text wrap not indicated in the design. Add a top padding of 40. We choose the spacing of the status to the furthest point of the set point. It's 25 plus the size of the set point 50, so that is 40. It would be a good idea to set the background color to the inner dial color so we can see the text later. Background color inner dial 2. We don't need the linear gradient. The top element inside the V-stack will be the temperature status, whose text value is the status raw value. Font, it's going to be 17 pixel in semi-bold, so that's headline. The foreground color, it's white at opacity 0.6. We said we'll hide the text in the event that show status is false. So let's do that. Show status. If it's true, let's keep it at 60%. Otherwise, 0. Additionally, we'll add an animation on the show and hide effect. Animation is in with duration 0.5 and the value is show status. In the middle, we'll insert the current temperature, text, temperature. We'll need to convert it to a string using string literal. And let's format it with the format specifier. and set it to %.0f. That's going to round it to an integer. Then set the font to system size 54, right? 54 pixels. And the color is going to be white. Foreground color, white. Now you can see that the text has its own padding on top and bottom. The last element in the stack is an SF symbol that represents the echo leaf. Image, system name, leaf.fill. The font is going to be 22 pixel in bold. So that title 2. Dot bold. And the foreground color, green. We're done with this summary view. Now we only have the scale to wrap in to complete the thermometer. Let's create another SwiftUI file. Name thermometer, scale, view. Again, we'll declare constants for the scale size, horizontal and vertical paddings. Private var, scale size as a CG float equal to 276. Let's copy this, paste twice. The second property is horizontal padding. And let's put in the vertical padding too. In the design, the padding values are from the side of the device, 20, and the navigation title, 25. 20, 25. Resume. Its view is going to be another Z stack. Let's change the background color so we'll be able to see the scale lines later. Copy the modifiers of the preview and paste. Resume. My bad, they are actually net properties. Before we continue on the Z stack, we shall create a function to return a view that is the individual scale lines so that we can repeat it many times. Under the body, font, scale line, at line as an int, it's going to return some view. I'm going to show one temporarily. The scale line is just a small thin rectangle. Let's fill it with the color. Scale line. Let's resume. And the size of the scale is 2 pixel by 10 pixel. We see one. Then we'll embed it in a V-stack with a spacer to spread them out. Command-click, embed in V-stack, insert a spacer. Also, with each line, we'll rotate by an additional 9 degrees because there are 10 lines per quarter of the circle. Be my guest if you want to count it. Rotation effect, degrees. We're going to convert it to double times 9. Let's re-indent this line. Control I. Now let's loop the scale line 21 times with for each 0 to less than 21 line in, scale line at line. Then set the frame size for all these scale lines. Frame, scale size. Remove the alignment again. Better. The whole scale is not at the right direction, so rotate it 90 degrees counterclockwise. You may apply the rotation to the whole Z-stack or to the individual lines. I'll go with the latter. Minus 90. Sweet. Surrounding the scale lines are 3 temperature markings. Make a Z-stack to combine them all. Then an H-stack inside to align the 10 degrees and 30 degrees horizontally. 10, Option Shift 8 for degrees. Insert a spacer. Text 30 degrees. Then add a V-stack to align the 20 degrees vertically. Spacer. Let's frame it with the size specified in the design. So we're going to use the original size of the device, 390, minus 2 times the horizontal padding. The height is 390 minus 2 times the vertical padding. Remove the alignment. We're going to change the font to 15 pixel. Subheadline. And change the color to white at opacity 30%. I forgot to mark the loop as the scale lines. Once these components are finished, we can go ahead and add them to the thermometer view. The first one is thermometer scale view. Then add the thermometer summary. thermometer summary view. Let's pass the same parameter values to thermometer summary view as in the preview for now. Dot heating, true, 22. Resume. In turn, the UI of the thermometer view is also completed, and so we can display it in content view. Here. Thermometer view. We'll add a top padding of 30. And a bottom padding of 60 to position it correctly. For the rest of this project, we'll work on its usability. We'll activate the drag gesture to allow the user to turn the dial to change the room's temperature. We'll include some animation over time as well, such as the progress in the ring and the appearance and disappearance of the status indicator. Let's take care of the temperature settings by first observing the current temperature. We'll declare a state for it. Go to the top. Add state, private var, current temperature as a CG float, default to 0. And on the pair of the thermometer, set the starting value. On up here, current temperature equals to 22. Consequently, the direction of the dial in degrees will depend on the initial current temperature. Degrees equal to current temperature divided by 40. Let me explain where I got this number. If the scale lines were to surround the thermometer in full, there would be a total of 40. So each of them equates to 1 over 40. We'll just need to multiply by 360 degrees after that. Once the current temperature is available, we can pass it to the thermometer summary view. So replace 22 by the current temperature. Now let's move on to the target temperature. But before that, declare constants for the minimum and maximum temperatures. Here. Private let min temperature of type CG float. Set the default value of 4. Copy and paste, change min to max. And its default value is 30. Remember that the target temperature is set by the user interaction depending on the direction of the dial. Therefore, we can declare a computed property for it based on the degrees. Var target temperature CG float return degrees divide by 360 times 40, and we can limit its value between the minimum and maximum defined above. First, max of that min temperature, then min of the result, max temperature. Assume. If we run the preview, the set point turns properly and stops at 22 degrees Celsius. Let's do the same for the ring. Priorly, we declared a state variable for the ring value, so I could demonstrate its animation by updating its value. As a matter of fact, the ring value should be calculated based on the current temperature. We'll need another computed property. So delete this line. Var ring value Cg float return current temperature divide by 40. Resume. Voila! It moves to the 20 degrees mark also. After both the current and target temperatures are available, we can make use of them to compute the status. Var status of type status. If the current temperature is less than the target temperature, it's heating. Return dot heating. Else, if it's the opposite, current temperature is greater than target temperature, return cooling. If neither, it means that the target temperature has reached. Return reaching. Now we can pass it also to the thermometer summary view. Status. Next, time to handle the drag gesture. It's going to be a bit complicated, so bear with me. The first thing to do is to create a function to calculate the angle from where the user turns the dial. So under the preview, extension, thermometer view, private func, calculate angle. It'll take the center point as a CG point and the end point as a CG point also, and it will return the degrees in CG float. The radians is calculated with the tan2 method. Based on those points. Endpoint dot x minus center point dot x. This one is going to be center point dot y minus endpoint dot y. Then we'll need to convert the radians to degrees. If you Google it, the formula is 1 radian times 180 degrees divided by pi. Let degrees equal radians times 180 divided by dot pi. At the same time, add 180 degrees to it. Not sure how to explain that, but without it, it won't work properly. 180 plus, put all of these in parentheses. Finally, return degrees. Now we're able to add the drag gesture to the dial. Here. This is why I grouped all the elements of the dial together. Dot gesture, drag gesture, unchanged of the drag value, we extract its location in terms of x and y. Let x equal to value dot value.location.x. Let y equal to value.location.y. We'll ensure to ignore the gesture if it falls outside of the outer dial. So let's create a constant variable for it. Private let outer dial size CG float equal to 200. Back to the drag gesture. Max of that 0. And then min of that outer dial size. For the y, we'll just copy this, paste, and change x to y. Then we'll store them in endpoint. Let endpoint equal to CG point x, y. On the other hand, the center point is the middle of the outer dial. Let center point equal to CG point outer dial size divided by 2. Same for y. Outer dial size divided by 2. After that, we can get the angle by calling our calculate angle method. Let angle equal calculate angle center point endpoint. Finally, update the degrees with the angle value. Test the gesture by turning the dial. Resume. It doesn't make sense that the set point can go beyond 30 degrees or below 4 degrees in temperature. Hence, if the angle is less than 36 or more than 270, we won't update the degrees. Just before updating the degrees, if angle is smaller than 36 or angle is greater than 270, return. Let's test again. All right. To better see what's going on under the hood, we can store the x, y, and angle values to state variables and display them on screen. That way, we can observe the changes in value. Go to the top, copy this, paste 3 times, change it to x, 0, y, 0, angle, 0. Then assign the values on the drag gesture. Self.x equal to x. Self.y is equal to y. Self.angle equals to angle. Then under the summary view, let's add a vstack. Resume this. Text x. Let's display the x and y. Let's display the y. Text angle angle dot formatted can copy this for the degrees. Now the text views are on top of the dial in black. So let's add a spacer to push them to the top and change its color to white. Okay, let's test the drag gesture again. As you can see, the degrees value has many digits. We should round it. Not only that, we should only allow to increment or decrement 1 degree in temperature at a time. In real life, it'd be half a degree, but here we'll simplify it. 1 degree Celsius is equivalent to 9 degrees in angle. We can turn the degrees to be divisible by 9 with the help of the remainder method. Here, angle minus angle dot remainder dividing by 9. Let's try again. Now that we understood everything, we can comment out all the code related to those test properties. By the way, the test angle should have been on this line. Afterwards, we will proceed to mimic the reality on how the room temperature progresses. We'll update the current temperature in time after setting a new target temperature. When we require the time, we can connect to the timer publisher. Let's do it here. Timer dot publish on every 1 second. No tolerance on the main thread in the common loop and remove the options. Then we'll connect automatically. And on receipt of that timer, we increase or decrease the current temperature every second based on the status. On receipt, timer, enter. So we won't need the time. Switch status. If it's heating, then increase the temperature. If it's cooling, decrease the temperature. If it's reaching, we'll just exit with break. We'll make sure to cancel the timer when the view disappears. On disappear, timer.upstream.connect.cancel. Let's resume and see how it goes. Nice. It's getting there. The last matter to tend to is the show status variable, one of the parameters received by the thermometer summary view. Declare a state variable for it on top. At state, private var show status defaulted to false, as when the app launches, we assume the temperature is reached. Now go back to the bottom. When that's the case, we hide the status. Show status is equal to false, or else we show it. Show status equal to true. Same here. Show status is equal to true. Also, go ahead and pass that newly available variable to thermometer summary view. Show status. Resume. Let's test it out. Now it's hidden. That's very good. And disappearing. Cooling. Reaching. And gone. That's perfect. Let's run the app in the simulator to make sure it works the same as in the preview. Stop this. Command R. Let's turn the dial. It seems to be working just fine. I hope you enjoyed this little project, though a bit long. Thank you for watching and see you next time.